Okay, so use mesh analysis to determine the amount of power supplied by the voltage. So mesh analysis, I like to always draw my meshes going the same direction. It's not required, but I think it is a good idea because otherwise it will tend to lead to mistakes. And then, so for anywhere that you have like an inside loop, you just draw a circle. I do mine clockwise, but it doesn't matter. You can do clockwise or counterclockwise. I do recommend that you do them all in the same direction. And then for each loop, you will go around and do a KVL for each loop. Now, we don't have to do that for loop 1, which is good because we don't really want to solve a system of three variables of three equations. We could, and by the way, if you are planning to stick with electrical engineering and take circuits 2 in the fall, I am strongly going to recommend now that you get the TI-36X Pro calculator. It's a $20 calculator that will do everything that you need for circuits 2. It does complex numbers better than the TI-84, and it does solve a system of three equations and three variables very nicely. So just throwing that out there. All right, but why don't we need to have a separate mesh equation for loop 1 here? It has a current source. And it has a current source on a branch that is just the current that we have labeled. If the current source was in the middle, we would have a super mesh and we would do something different. But it's this current, this 9 amp current, is exactly I1, and it's going in the same direction as I1. So we know that I1 is 9 amps. So I don't need to do a separate equation for that one. Now, I'm going to still call it I1 for right now as I do my middle loop, but I'll come back and substitute in I1 in a minute. So now for I2, as I go around this middle loop, when I come to a resistor, the voltage drop across that resistor is going to be the value of the resistance times the current going in the direction that that I'm traveling, and then minus any current that's going in the opposite direction. So anytime you come to a branch that's shared between two loops, you're going to have the current for that loop minus the current for the other loop. So coming to this 4 ohm resistor, it'd be 4I2 minus I3. And then when I come to the 2 ohm resistor, that'll be 2 times I2 minus I1 equals 0. Now, apparently in my notes, I labeled my loops in the opposite order, I3, I2, I1, so already my notes don't match, so I can't check myself. All right, now going around loop 3. When you come to a voltage source, if in the direction you're traveling, you're going into the positive terminal, then you make it positive. If in the direction you're traveling, you're going into the negative terminal, you make it negative. So in the direction I'm traveling, I'm coming into the positive terminal, so that's plus 40. And then the next thing I come to is the 4 ohm resistor, so plus 4. And then in the direction I'm traveling, it's I3 minus the current in the other direction is I2. And then when I get to the 8 ohm resistor, that just has I3, so plus 8I3 equals 0. And then I have two equations, so let me multiply these through. So I get 4I2 minus 4I3 plus 2I2, and then I1 is 9, so minus 18 equals 0, or 6I2 minus 4I3 equals 18, and then I'll divide everything through by 2 because I can. 3I2 minus 2I3 equals 9. Okay, so that's for my first equation. And then my second equation, I'm going to take the number to the other side. So the other side will be minus 40. And then I have 4i3 minus 4i2 plus 8i3, or 12i3 minus 4i2 equals negative 40, and I'll divide through by 4, 3i3, and let's see, and that's a negative 1i2, so minus i2 plus 3i3 equals negative 10. All right, and then negative i2 plus 3i3 equals negative 10. I think I can solve this. So minus 3i2 plus 9i3 equals negative 30. And then I will add that to my other equation, which was 3i2 minus 2i3 equals 9. And I get 7i3 equals negative 21, or i3 equals negative 3. And then if i3 equals negative 3, negative i2 plus negative 9 equals negative 10, or negative i2 equals negative 1, or i2 equals 1. Did I make any mistakes with any of that? Okay, and let's see what the question is asking. Determine the amount of power supplied by the voltage source. So now I want to look at the voltage source. And I know that power equals IV. Now, what current do I know? I know I3, and I3 is going in this direction. So I3 going in this direction is entering into the positive side of the voltage source. So my power is going to be my value of I3, which is negative 3, times positive 40, which gives me negative 120 watts. But usually, rather than saying negative 120 watts, the way we report this answer is if it's negative, is power being absorbed or supplied? Supplied. So the way we write this is 120 watts supplied. You don't say negative 120 watts supplied, because that's like a double negative. Okay, so any questions on that one? Anything I can explain a little further?